Okay, let's unpack this. Today we're jumping into a deep dive, and it's
Hmm.
fueled by some really fascinating source material. We're looking at a question that, frankly, pushes the boundaries of what we think life needs.
Right.
We're talking Saturn's moon, Titan. And the big question is, could life exist somewhere else in our solar system, but completely unlike life here? Maybe not even needing water.
Exactly.
So our mission here, based on this text, is to figure out why Titan is seen as such a compelling candidate, albeit a very, very bizarre one.
It really is. Because our standard assumption, and the source reinforces this, is that life needs water. Period.
Right.
Every single thing we've ever found on Earth, no matter how extreme the environment, it's fundamentally water-based.
Right. Water's the universal solvent here.
Hmm. The source talks about its incredible ability to dissolve all the molecules needed for, well, complex biochemistry. But when you look at Titan through the lens of this material, that whole assumption gets seriously challenged.
And this is where it gets really strange based on what the source details. Titan's surface, bone dry, of water, anyway.
Yeah, no liquid water there.
Yet we know from data like Cassini and the Huygens probe, the text mentions these, it has landscapes that look eerily like Earth. Rivers, lakes, even seas.
Uh-huh.
The catch, they're filled with liquid methane and ethane. And the temperature, it averages around, negative 180 degrees Celsius.
-180 C. Yeah.
Just picturing that feels completely alien, doesn't it?
It is a radical departure.
Yeah.
And the source really explores this idea. Could methane and ethane, even in that extreme cold, could they do the same job? Could they be the solvent, like water is here? Could they allow for a whole different set of chemical reactions for life?
So what does the source tell us about the ingredients on Titan? Are the building blocks there?
Well, it points out that many basic things are there, yeah. Kind of similar to early Earth, actually. You've got energy from the sun, you've got loads of organic molecules. These get created when UV light hits the atmosphere.
Like acetylene, cyanogen, stuff like that.
Exactly. Acetylene, cyanogen, even benzene. The text mentions those. Plus, you have dynamic processes, rain, evaporation, wind, distributing things.
Okay, so some similarities. But the big difference, as you said, no liquid water, it's liquid hydrocarbons instead. How does that just reshape everything?
That's really the core of the hypothesis presented here. If life exists in that environment, it would have to have a totally different chemistry. It wouldn't use oxygen like we do.
Right.
The source suggests it might consume other molecules available in that methane soup. Specifically, the idea is raised that this kind of life could potentially consume hydrogen, maybe acetylene.
And isn't there some data point from Cassini and Huygens that the source highlights? Something that might kind of hint at this?
Yes, it's intriguing. It's not proof. The source is very clear about that.
Okay.
But hydrogen and acetylene, they're produced way up high in Titan's atmosphere. But the data showed they were, well, conspicuously absent near the surface.
Right, where the liquid lakes and seas are.
Exactly. So the source presents it as this anomaly in the chemistry that, sparks the hypothesis. Could something be consuming these molecules down there?
It's a piece of the puzzle, then, for imagining this completely different kind of life.
Precisely.
Okay, so let's quickly recap what we've pulled from this source. Earth life, universally water-based, water's the solvent, Titan, radically different, liquid methane and ethane instead.
Mm-hmm.
It lacks water, but it does share some basic ingredients with early Earth.
Right, the organics, the energy.
And the hypothesis, based on this environment, is maybe methane-based life exists, potentially consuming things like hydrogen or acetylene. And we have that interesting Cassini-Huygens data showing those specific molecules seem to be missing near the surface.
Exactly. And that leads to a really fascinating final thought, something the source implicitly raises for you, the listener, to consider. If life can use different solvents, like methane or ethane, what does that imply for the potential for life on just countless other worlds we know nothing about, maybe worlds we currently dismiss because they don't have liquid water? What other signs of life, what other chemistries might we be completely missing just because we're only looking for things familiar to us here on Earth? That's a concept that really expands the imagination, I think.